Welcome to the deep dive. So if you're working in JavaScript or TypeScript, maybe on bigger projects, you probably know this feeling. Code bases grow, teams get bigger, and suddenly builds just take ages.
Yeah, it's a common pain point.
Exactly.
Yeah.
So today, we're diving into that world. We're looking at how these large monorepos can get bogged down, get slow, and what one tool, Turborepo, is trying to do about it.
That's right. We've been looking at the Turborepo docs, specifically the intro, and also a pretty helpful YouTube explanation. And our goal really is to understand that core problem, first scaling these big code bases, and then unpack how Turborepo actually tries to solve it. What are the key techniques it uses? And maybe most importantly, how could you get started with something like this?
Yeah, and the big claim we kept seeing was pretty eye-catching, wasn't it? What used to be this agonizingly slow compilation process for massive projects is now being called blazingly fast because of tools like Turborepo. It really makes you wonder, how do you get that kind of speed boost?
It's a good question.
Okay, so maybe let's start with the basics. What exactly is a monorepo?
Well, fundamentally, it's about bringing multiple projects or maybe sub-projects together, all under one single version control roof, usually Git.
So instead of, say, a separate repository for your backend API, another for the front end.
Exactly. And maybe another for a shared component library or some config files. You bundle them all into just one repository.
Which is the opposite of what people call the polyrepo approach.
Precisely. Polyrepo is just, many repos, one for each distinct project.
Okay, so one big repo versus lots of small ones. What's the draw? Why are teams doing this?
The sources point to a few key advantages. One big one is collaboration, especially for, say, medium-sized teams. It can make things smoother. Everyone kind of sees the whole picture.
Better visibility.
Yeah, and dependency management can often get simpler, too. You can have, a single place to manage versions for shared libraries, a single source of truth for many things.
And what about making those big, sweeping changes, refactoring something that touches multiple parts of the system?
That's another big one. They call them atomic changes. If everything's in one repo, you modify the code, run the tests, commit all in one go. You're not juggling pull requests across 5 different repositories.
Right, that sounds way less painful.
Yeah.
Avoids that whole synchronization nightmare.
Absolutely, it keeps things bundled. But, and here's the catch, as these things scale up, you hit what they call the Monorepo problem.
Okay, the downsides. What are they?
Well, for starters, Git itself can start to feel sluggish. Just the history, tracking changes across potentially hundreds of components or packages, it gets heavy.
And build times. That's usually the first thing people complain about, isn't it?
Oh, definitely. If you don't have tooling to optimize it, the naive approach is just rebuild everything. Every single time anything changes, even a tiny bit.
Ouch.
Yeah, and think about it. A decent-sized monorepo might have thousands of individual tasks, lint this package, test that one, build this app.
Thousands.
Yeah, easily. Running all of that from scratch every time, especially in CI/CD pipelines, it's just incredibly slow and wasteful. You need something smarter, something that knows what actually changed.
Okay, so that's the setup, and that's where a tool like Turborepo comes in, positioning itself as this high-performance build system.
Exactly. It's designed specifically to tackle those monorepo scaling issues, though they also say it can speed up even single package projects.
And they threw out some pretty big numbers, right, about saving time and money.
Yeah, quite impressive. They mentioned saving years of cumulative engineering time and millions in compute costs. There was that specific figure. Over 2.9 million hours saved for users.
Okay, 2.9 million hours, that's a lot. How does it achieve that? What are the core ideas, the things it tries to get that speed?
The documentation highlights really 4 main concepts working together. First, and this is fundamental, is incremental builds, meaning it remembers what it's already built. If the inputs to a task haven't changed since the last time it ran, it just skips the work entirely. It reuses the previous output.
Okay, so it avoids redoing work unnecessarily. Smart.
Very smart. And building right on top of that is something called content-aware hashing. This is really the key to knowing what's changed accurately.
Content-aware hashing.
Yeah.
How does that work?
Instead of looking at flimsy things like file modification timestamps, which can be unreliable.
Right, like just checking out a branch can change those.
Exactly. Turborepo actually looks at the content of the files involved in a task, plus the content of its dependencies, and generates a unique identifier, a hash, based on that content.
So if the content is identical, the hash is identical.
Precisely. And if the hash matches the one from a previous run, Turborepo knows the output is still valid and can be reused or skipped. No guesswork.
That's clever. Okay, so it knows exactly what needs work. What else?
Third, it tries to max out your machine's potential using parallel execution. It looks at your task dependencies, what needs to run before what, and then runs everything that can run simultaneously in parallel across all your available CPU cores.
So it keeps the CPU busy, less idle time waiting around.
Right. Minimizes wasted cycles. And the fourth big piece, especially for those cost savings they mention, is remote caching.
Remote caching, so sharing the cache.
Exactly. It doesn't just cache task outputs locally on your machine. It can store them in a shared remote location. Think like a cloud bucket or a dedicated service.
Okay, so what does that enable?
It means if your teammate builds a specific package and then you pull the latest changes, your machine might not need to build it at all. It can just download the already built output from the remote cache because the content hash matches. Same goes for your CI server.
Wow, so CI builds one commit, pushes the cache, and then the next CI run, or even my local machine, can just pull down those artifacts instead of recomputing.
That's the idea. It massively reduces redundant computation across the whole team and all your build environments.
Okay, so putting it all together. Content hashing knows what changed. Incremental builds skip the unchanged work. Parallel execution does the needed work faster. And remote caching shares the results of that work.
You got it. That's the core loop that delivers those performance gains. It's all about minimizing the actual computation needed.
So if someone listening is thinking, okay, this sounds pretty good, maybe I should try this, how hard is it to actually adopt? Does it mean rewriting everything?
No, not at all, according to the sources. They really emphasize ease of adoption. It's designed to be incremental. You can often add it to an existing Monorepo or even a single package repo in just a few minutes.
Really? How does it integrate?
It basically works on top of what you already have. It uses your standard package.json scripts, the build, test, lint commands you've already defined. You just add one new configuration file, turbo.json.
Just one file.
Primarily, yes. And it works with whatever package manager you're using, NPM, Yarn, PNPM. It leverages the existing ecosystem conventions.
That sounds quite seamless.
Yeah.
What if you're starting a new project?
There's help there, too. They have a command, something like create turbo, that scaffolds a new monorepo for you, often setting up that common structure with an apps directory and a packages directory for shared stuff.
And that turbo.json file, that's where the magic happens, where you tell it how things connect.
Yeah, that's where you define your pipeline. You tell Turborepo about the tasks you have, build, test, lint, etc., and crucially, how they depend on each other. Like, maybe the test task depends on the build task finishing first for that package.
Okay, so you define the graph.
You define a graph, and Turborepo figures out the optimal execution plan, what can run in parallel, what needs to wait. They even mention a neat integration example with Next.js.
Right.
Using a plugin like Next Transpile Modules, it allows a shared UI library package, for instance, to only get compiled when it's actually imported and used by an application, rather than having its own separate, potentially redundant build step.
Ah, so it avoids building library code that no app is currently using in that specific build.
Seems like it, yeah. Little optimizations like that which add up. And they also mention having tools to like visualize that task dependency graph or profile your builds to see where time is being spent.
Which sounds super helpful for debugging complex builds.
Definitely. More visibility is always good.
So bringing it back to the listener, why should you, listening right now, really care about this stuff?
Well, if you're a developer, especially in the JavaScript or TypeScript world, and you're dealing with multiple related projects, maybe sharing code between them, or you're just plain tired of waiting for slow builds, understanding monorepos and how tools like Turborepo optimize them is pretty relevant.
It directly impacts your day-to-day, right?
Yeah.
Development speed, team collaboration, even infrastructure costs.
Absolutely. It hits all those points.
So this deep dive really highlights that while monorepos offer some powerful advantages for organizing code and collaboration, they definitely come with scaling challenges, particularly around build performance.
Right. But tools like Turborepo are tackling those head-on with some clever techniques that content-aware hashing, the parallel execution, the smart caching, to claw back that performance and efficiency.
It's really about optimizing the workflow, isn't it? Finding the redundant work and eliminating it.
Exactly. And that core principle aggressively avoiding redundant work, whether it's over time or across different machines or environments, it makes you think. Given how effectively this approach seems to optimize something as fundamental as the build process,
Yeah.
well, it raises a broader question, doesn't it? What other common bottlenecks exist in our software development lifecycle? What other routine tasks could be dramatically improved if we applied this same kind of focus, using intelligent tooling to avoid repetition and maximize efficiency?
That's a great question to ponder. What else could benefit from this kind of thinking? Okay, thank you for joining us for this deep dive.